Today we will learn Earth's magnetic field. Earth is a magnet and it is directed. The field is directed from 11.3 degree north of south. From here to 11.3 degree west of north up to here. So you can consider that a magnet is lying inside the surface of Earth with its north pole towards downward direction and its south pole towards geographical north direction. Now when you place a compass needle in vertical plane at these points, firstly along geographical north pole, you will find that the red end of the compass needle, that is north pole, is pointing exactly downward direction at 90 degree. It becomes exactly vertical. Now if you place the same compass needle on horizontal plane, you may find that the needle arrange itself comes to rest in any direction. So it suggests that in horizontal direction there is no force acting on the needle at this point, but there is a force acting on the needle in vertical plane, and this point is called magnetic north pole, or you may say north-seeking pole. Similarly, in south direction, here is a point where if you place a magnetic compass needle horizontally, parallel to the surface of Earth, then it may arrange in any direction. The needle can settle itself, stand to still in any direction, which suggests that no force is acting on the needle horizontally. But if you keep the compass needle vertically, then you find that the needle arranges itself in a direction such that the red end of the compass needle is perpendicularly away from the surface of Earth. So here field is outward. Now the magnetic north pole, what is a pole? Pole is a point where in horizontal direction there is no magnetic field and the magnetic field is exactly vertical. This is your north pole, north magnetic pole or north-seeking pole. Similarly, south-seeking pole or south magnetic pole is a point on the surface of Earth where if you place a magnetic compass needle horizontally parallel to surface of Earth, the needle may settle in any direction. It suggests that no force is acting along horizontal direction. But if you keep the compass needle in vertical plane, the needle arranges itself exactly perpendicular to surface of Earth. So such a point is called pole, where there is no force in horizontal direction and there is vertical force on the needle. So this is your south magnetic pole and this is at latitude 79.74 degree and this is towards south. This is latitude of south magnetic pole. Longitude is your 108.22 degree and this is, you can see, towards east, whereas the position of north magnetic pole in terms of latitude is 79.74 degree north and longitude is 71.8 degree west. So let me show you what is the meaning of latitude. Here you have a horizontal plane circle on the equator, and then you draw another horizontal plane circle which passes through the pole. Now, when you make a straight line from pole up to the center of the earth, then you find an angle forming in between the two lines, a line coming from the pole and equator. And this angle is actually called latitude angle. This is equal to 79.74 degree towards northward pole. So this is latitude of pole. And if you draw vertical circles, not horizontal, here you can see we have vertical circles, then the angle made in between two vertical circles, one which is passing from prime meridian and other which is passing from north magnetic pole. If you find the angle between the two vertical circles, this angle will give you longitude of this point pole, north magnetic pole, and longitude is given by 71.8 degree west. So this is how you will be finding longitude and latitude. Now, earth magnetic field at different places are different. They vary from point to point. Earth has magnetism. It has magnetic field all along, and it is of the order of 10 to the power minus 5 Tesla. So, there will be some cause of this earth magnetism, and a simplistic figure you may think of about the cause of earth magnetism is a huge bar magnet which is running in between the two magnetic poles inside the surface of earth, and this is causing magnetic field you may think of. But such a regular shape naturally you do not find anywhere. So this theory does not appeal. There is one more theory, that is your electronic theory. So our earth, which has inner surface, inner part called core, it is very highly heated, and due to which this inner part of earth is in molten form. Moreover, there is difference in temperature between the two outer and inner layer of the core, and this temperature difference causes a convection current in molten rock material present inside the core. This convection current may be cause of earth magnetism. So this is one theory. The outer core is molten due to high temperature over there. And also there is a convection current due to temperature difference. Between inner part and outer part. So a convection current is set up, and convection current is set up, and this is the cause of earth magnetism. Now this earth's magnetism is not uniform. It changes with time and it is not consistent everywhere. And one cause of this may be due to changing pattern of this flow of convection current. Due to changing pattern of this flow of convection current, maybe the pattern of magnetic field also varies. This may be one cause. Cause of changing pattern So this is your changing pattern of changing course of flow of current. And there is one more reason, that when solar flares, solar charges reaches to our poles, they are acted upon these poles, and in return the field of magnetic poles are also affected by these moving charges. So this may be another cause of changing pattern of magnetic field. The solar radiations consisting of ions are acted upon by these magnetic fields on pole. And in return they also affect the magnetic field pattern of the pole. Magnetic field of earth varies with time, and there is short-term variation and long-term variations. In London it was noted that in between the period of 1580 AD and 1820 AD there was a change of 3.5 degree in declination. Magnetic field lines changed its direction by 3.5 degree. So this is a short-term variation which took place in only 2 or 3 centuries. Now there are long-term variations that took place in millions of years. You may find a total reversal of magnetic field pattern in such long duration. So if you have magnetic field lines along this direction today, it may change to some other direction. It may change to some another direction along some other time period. And if at that time there takes place any volcanic eruption and basalt material get accumulated on the surface of Earth. So basalt material contains iron, nickel, and therefore they will be affected by magnetic field pattern of that time. They will arrange themselves as per the magnetic field pattern of that time. And they will show, that places will show magnetic field in that very direction only, even today. So we have several spots on the surface of Earth which have their magnetic field direction different from the magnetic field of Earth. And this magnetic field can be totally known. All the magnetic field on the surface of Earth can be explained if we know the three elements of magnetic field of the Earth. The three elements of Earth's magnetism. The one is called declination, second element is your inclination. This is also known as D. And third element of Earth's magnetism is horizontal component. Of Earth's magnetism. Declination is one of the elements of Earth's magnetism, and this declination varies depending on positions. So any one position, suppose at this position, you may find declination, that is angle between magnetic meridian at that point and geographical meridian at that point. This angle is represented by delta. Here delta is your declination. And magnetic meridian, it is a plane surface. When you cut Earth at that point, which is passing through magnetic north pole and magnetic south pole and the point itself, that plane surface is called magnetic meridian. You can draw any plane taking any 3 points. So taking these 3 points, I have drawn magnetic meridian. In the same way, we have geographical meridian. The plane cut part of Earth which passes through the 3 points, geographical north pole, geographical south pole, and the point itself is called geographical meridian. So when you approaches towards poles, you will find that angle of declination increases. And when you reach exactly in between the 2 points of magnetic north pole and geographical north pole, you find that this angle becomes highest and it is of 180 degree. So highest value of declination is 180 degree, pi radian, and at equator it has smallest value. It will be nearly equal to 0 degree. Inclination or D is one of the elements of Earth's magnetism. So when you place a compass needle in vertical plane such that it is free to rotate in vertical plane, then you will find that the compass needle is making certain angle with horizontal direction. That angle is called inclination. Here in this figure you can see I have placed a compass needle in vertical plane on the surface of Earth, and the needle is making certain angle with horizontal direction. So this is your angle of inclination or angle of dip. Now if you place the compass needle near equatorial plane, near equator, then you will find that the compass needle is exactly along the horizontal direction. So here angle of dip becomes equal to 0. Now when you reach to any one of the poles, magnetic south pole or magnetic north pole, you will find that the compass needle becomes exactly vertical at that point on the surface of Earth, exactly vertical. So it is making an angle of 90 degree. Here you have horizontal direction and the needle is pointing in this way. Needle is pointing in this way. So angle between horizontal direction at this point and the direction of magnetic dipole moment, this angle is called angle of dip. So at magnetic south pole and magnetic north pole, the angle of dip is 90 degree, and at equator the compass needle, though it is free to move in vertical plane, it remains horizontal, and so angle of dip becomes equal to 0. Now we have third element of Earth's magnetism, the horizontal component of Earth's magnetism. So if this is your geographical meridian and this is your magnetic meridian, of this very point, this is geographical meridian, magnetic meridian, and if you take a compass needle and place at this very point, so you will find that compass needle is resting in magnetic meridian only, making certain angle with horizontal direction. This angle is called angle of inclination. This is your angle I or dip angle. The magnetic compass needle at this point is pointing towards Earth's magnetic field B of A, because compass needle always points towards magnetic field. So this is the direction of Earth's magnetic field. Now it will have two components. Horizontal component will be BE cos of angle of inclination. This is your horizontal component of Earth's magnetism. And vertical component of Earth's magnetism can be obtained by taking component of magnetic field of Earth along this direction. And its component along vertical direction is BE sin I. So magnetic field along vertical direction is BE sin I, and magnetic field along horizontal direction is BE cos I. And now when you divide the two, you will find that BV upon BH is equal to tan of angle of inclination, and therefore BH tan I is equal to BV. So all these are three components of elements of earth magnetism, and using these three elements we can find magnetic field strength of our earth at any point. When you place a bar magnet in earth's magnetic field and in the direction of magnetic field or in opposite direction of magnetic field, then you will find at 2 points the net magnetic field due to earth and due to bar magnet, they become equal to 0, and that point is called neutral point. Here you can see a magnet's north pole is facing towards magnetic north pole. It is your magnetic north pole, which is actually a south pole. So magnetic field lines of the earth are going all along this way. These are magnetic field lines of earth. Whereas magnetic field lines of this bar magnet that runs from north pole to south pole in this way is here. So at this point, at a perpendicular bisector point, here you can see the fields are in opposite direction. The field due to a bar magnet is towards downward direction and field due to earth is towards upward direction. So if at any particular point, at any particular distance in perpendicular bisector plane, if the field becomes exactly equal, and here direction you can see the direction is already opposite, so field becomes 0 at this very point, and this point is called neutral point. Now there is one more placement of your bar magnet. If you place your south pole of bar magnet in magnetic field of earth such that your south pole is facing magnetic north pole, means it is facing another your south pole. Okay, here is hidden south pole of earth. So these are the magnetic field lines of earth. Magnetic and your bar magnet has its magnetic field line in the same direction. So in perpendicular bisector plane, the lines are along same direction. They will not cancel each other. They will add at these points. But there is a point along axial direction where here you can find that the field lines are entering inside the bar magnet, your bar magnet from here. And the magnetic field lines are going upward. So there is a point here where you will find no magnetic field lines. It is devoid of any magnetic field lines. So this is also called neutral point. It is your neutral point. Means net magnetic field at this point, at point P, becomes equal to 0 due to magnetic field due to earth and magnetic field due to this bar magnet both cancel each other at this point. So these places are called